Hello everyone. So again, I apologize that I am once again absent. I did want to make sure that we could get through as much of the rest of this intro packet that we were working in as we possibly can. If you don't have a copy of this, please look on with the one that is digitally already uploaded on Google Classroom. I do not have any extra printed copies. I am sorry for that. So thanks to the pep rally, we only got through the first 4 of these boxes regarding our angle definitions. Luckily, the ones that we are still approaching, you can see the 2 that are below where we ended. I'll erase the little 2b here. It says, hey, here's complementary angles, here's supplementary angles, 2 very similar words, 2 very similar definitions. Complementary angles are 2 that have a sum of 90 degrees. Supplementary have a sum of 180 degrees. Some teachers like to say, oh, look, I can take this C and sort of make it into a 9, and that's why you see 90 here. And supplementary, it's kind of tough to do with that, but you can sort of make this a 180 kind of thing. That's less important than just understanding what the meaning is. These 2 angles, whether they're complementary or supplementary, you could have a pair of angles that are adjacent, the ones that, like we see right above this, have that common side, or they could just be floating off in space on their own. This 27-degree angle, this 63 angle, they never actually touch at all, but they will add to 90 degrees. Same thing over here, whether it's 2 angles that are adjacent or 2 angles that just are sort of chilling on their own, still will add together to equal 180 degrees. Down here, linear pair, this is actually one of the most important concepts that we'll have, because again, I remember saying in our last class how, hey, when you have 180 degrees, that's one of the most important numbers that we're going to deal with this year. Here is the major use of it. That 65 and that 115 up in this box, they're going to be very important for that same idea. This linear pair idea that says if you have 2 angles that are adjacent, they have that one line, that ray in common. When you combine them together, no matter where they might be, you're going to get a straight line. You're going to get those 2 angles add together to equal 180 degrees. Now, you can have any number of angles that combine together to give you a full straight line. We just say a linear pair would be, hey, it's just the 2 of them. Together they will add to 180, so they are both adjacent and supplementary. I'm going to come back to this box in just a few minutes. I'd rather focus on the more basic stuff, which is a lot of stuff, again, with 180 degrees, this idea of linear pairs. It's going to be very useful to us whether there's algebra involved or not. Speaking of algebra or not, we're going to get through, I think, most of the next 2 pages of this. So the first 3 pages we should fill in, and then I'm going to ask you to do a lot of these on your own. Question number 1. When you approach problems like these, I know we didn't get a chance to go over any examples together, but you're going to see from me, and I'm going to do it in the notes, I'm going to do it when we do it together in class. The very first thing you're going to see from me, the measure of angle 1 is 40 degrees. If you have those lovely little markers in here that say here's angle number 1, here's angle number 2, perfect. I would like to see you get into the habit of then actually writing that 40 degrees in where that angle is. Likewise, angle AGB. And remember, just like on the Delta Math section, if you have to, connect the dots. AGB. A to G to B. Boom, I can see which angle it is that I'm talking about here. I'm going to throw that 25 degrees right inside of it. And even just that little bit of visualization is going to help me to understand what has to happen for the rest of these problems. Now, my next question asks me about angle AGF. Again, if you're still getting used to it, connect the dots. You can see where that angle is that I've highlighted. That's the thing we're asked to find here. And here's where that idea of a straight line being 180 degrees is going to be so useful to us. Because as you see here, I've got a bunch of different straight lines all cutting through this middle point, all of them intersecting at point G. Right now, I know 1, 2 angles. I'm looking for a 3rd angle here, and those 3 angles together are all formed by this straight line here. And if I only focus on that straight line, and here's something that you can do if you have yourself on a piece of paper. I'm lucky enough to be able to just white it out, but feel free to take a piece of paper and just cover up the part of this figure that you don't care about right now. Like these 2 lines down here, they're kind of just excessive. They're creating more work. We don't care about anything about point E or D yet, but we're going to eventually, once we get some information based off of this. As always, a straight line is 180 degrees. And so if I know that this whole thing is equal to 180, this whole thing is equal to 180, all I have to say is, well, say hello to two angles that together will give me one larger one. And if I want to find what has to go in this lovely little corner here, I take my full 180 degrees and subtract that 65 away. And this concept, it seems like it's relatively simple. We did addition and subtraction. That concept is going to form a huge basis for all of the work that we do when we try to put this all together. Once I know that I have 115 degrees now in this corner here, we don't have to do any more math in this problem. Once I then go to find the other ones, the measure of angle 2, well, go ahead and look at this real fast and say to yourself, which angle is that going to match with? And hopefully it's not too hard to see that these two angles are right across from one another. They are vertical angles directly across the vertex, point G. And if that's the case, no math necessary. Since it's 25 degrees up above, it'll be 25 degrees down below. And you can create that same idea for any pair of angles that are directly across the intersection from one another. Since angle 1 is 40, angle FGE is also going to be 40 degrees. And of course, process of elimination would say, I've got this one angle left. Heck, feel free to look at this in any number of ways. Here is a straight line that is 180 degrees. You still have a 25 and a 40 degree angle here. You're still going to be doing 180 minus 65 and finding that this is still going to be 115 degrees. That's why vertical angles actually are always the same, because you can do that with any pair of lines that you want. So when it's all said and done and I get rid of all of these lovely extra pieces, with just that idea that a straight line is 180 and just that idea of, again, vertical angles across from one another sharing a vertex, doesn't have to be up and down. Vertical here doesn't mean up and down. It means they share a vertex. Boom. I can fill in what I need to fill in. Now, this is easy enough for a first question because there's no algebra. There's no solve for x. Even the ones where there are solve for x, though, hopefully they're not going to be too bad. If you were okay with the delta math section that I gave you when I was absent last week, I think this one's going to be pretty easy. Comparatively, at least, a lot of these are a lot less excessive. You certainly won't have to do a lot of the distribution that you did on that delta math problem. But I'm still going to try to do this the exact same way. Step 1 for me is, as soon as I see any information, let me write it in where it has to go. I know that angle 1 is 5x plus 32. I am told the measure of angle 3 is 3x plus 64. And if I've got both of those things down, I stare this drawing down and I say, oh, well, this one's even easier than the previous question because I don't have all of those different angles to worry about. I can see right now, oh yeah, angles 1 and 3 are right across the intersection from one another. That might be a horizontal line I just highlighted, but remember, those are still vertical angles because they share a vertex. And if they are vertical angles, then your box up on the first page says what you're going to do is, oh, here's my measure of angle 1. Here's my measure of angle 3. And those two things, since these angles are vertical, must be equal. You're going to notice when I send out the notes for this, I'm one of those people who says if you want to do the railroad tracks, if you want to do whatever it takes to make sure that you have the correct math here, the correct algebra here, please do it. Because that's going to be the thing that helps you the most to make sure that at the end of this problem, oh look, I'm going to subtract my x's both over to the same side. I now have 2x. Then I can worry about moving my numbers. Some people, some of you may like to do both of those things at the same time, subtract the 3x over, and then simultaneously move the 32 over. That's fine. Nothing wrong with it. But I am going to show every single boring step for a pretty long time until I'm sure that we're okay with keeping up. I'm not intending for the algebra here to be too miserable. We will see some negatives, we will see some fractions or decimals here and there, but the important thing is that at least we're hoping when we plug it back in, it will make some sort of sense. The other thing you'll need to watch for is that you're actually answering the question that was asked. This says find the measure of angle 4. Here's angle 4, and that's not something we were told about. That's not something we were given information about. What I do see is that once again, I have a straight line. And anytime I have a straight line, that has to equal 180 degrees. So again, as I go ahead and do my fancy, I'm going to white out the part of this drawing that I no longer care about because I just need one angle. I could have done it with angles 3 and 4. I chose to do it with angle 1 and 4. Well, spoiler alert, because it's actually going to be very easy for me to plug my x value back in here. Yes, in order to find angle 4, I do need to plug back in and find something. It's just that that something is angle 1 first. I do need to know how many degrees that is before I can go ahead and actually do my calculation, my last step. And if I can grab a calculator and say that 5 times 16 is 80, then I'll know the measure of angle 1 is 112 degrees, 80 plus 32. If that's 112, and I already know that a straight line is 180 degrees again, as soon as I can just take that thing, subtract away the 112 that I already knew, and I'll see that my answer here is a 68-degree angle. You might see it just written in there. You might see me write measure of angle 4 is equal to 68 degrees. These two things mean the same thing to me. If you just write this in that corner and circle it, I'll understand what you mean. You have labeled angle 4 as 68 degrees. You'll see this more frequently in my answer keys, just so that we're clear. But the math here hopefully isn't so bad. The thing that you will have to watch out for, and the thing that is the most confusing about this, is the understanding that not all questions are going to be solved in the same way. In question number 2, we said that these two angles that we knew, the two pieces we were given, were equal. That is most assuredly not always the case. And you're going to see in these next few examples literally how these things can be different each and every time. I am going to go through these quickly because I don't want this video to be too terribly long. But I do want to just make sure that we're seeing how these different angle things can come in here, and also why it just might be nice, again, to make sure your very first step is to see where these things go. It's not going to be quite as useful right now, but trust me, once we get into some more complex problems, you're going to want to see these things directly on your screen so that it helps you to recognize, okay, what is the math here that I'm supposed to be doing? Well, the math here is say hello to two angles, again, that lie together on a straight line. You will get bored of saying that a straight line is 180 degrees, and that's my hope, is that you do get bored. Because if you're getting bored, that means it's something that is now more intuitive. It's something that you understand. It's something that is more helpful. But again, don't fall into the trap of treating this exactly like we just saw in question number 2. I'm given two angles. Here I said they were the same. Well, these two clearly aren't. They're very different, whether you want to try to trust the drawing that you see or trust the fact that these two are lying together on a straight line. And that means there's some additional information or some other information that we need to actually say about them. They're not equal to one another. When I take those two angles and combine them together, I will get that whole straight line. Angles 5 and 6 in this drawing are a linear pair. And therefore, when I add those two angles together, I am hoping that I'll be able to get 180 degrees. Similar thing to last time, if I even decide to draw my railroad tracks or whatever, please keep in mind now that all of my x's, they're on the same side of the equal sign. I want to combine those like terms and get 10x. I want to combine my 44 and my 36 being on the same side to get 80. Then, now that I've taken care of all the work on the left-hand side of my railroad tracks, that's when we can start moving stuff over to end this. And again, to start off, I'm hoping that you're going to notice that these are not the worst numbers in the world. That 10 times 10 is going to give us 180, so x is equal to 10. Awesome. That's this part. Please, again, make sure you finish the question. Find the measures of both angles. And when you're done, please make sure that that makes sense. Please make sure that the numbers that you get are somewhat reasonable. That the measure of angle 5 says take 7, multiply it by 10. Instead of x, it's just 10. And if I do 70 plus 44, I should get 114 degrees. So here's my 114. Cool. I just need to find the other one. You can try to trust that this is the right math and just do 180 minus 114 to see how many degrees this would be. I would highly suggest, of course, plug your value of x in there and make absolutely sure that your algebra says what it should say, that you get the number that you're expecting to get. And oh yes, 30 plus 36 does in fact give me 66 degrees. So hooray for everything. We've got our final answers here and we're good. But again, don't fall into the trap of thinking that it's always going to be the same relationship. Here we saw in question number 2, two angles that were equal. Here we saw two angles that were supplementary. They added to 180 degrees. Question number 4 explicitly tells you that two angles are complementary. The thing that question number 4 is missing, though, is a drawing. You don't have to do a drawing if you're comfortable with what this word means, but it can't hurt. If you feel like saying, I know complementary means I have a right angle, it has 90 degrees, and then draw yourself, I don't know. I have no idea whether angle 7 or angle 8 is larger, but the great news about our drawings, and you'll hear me mention this a lot during the course of the year, is that we don't usually have to assume that they are drawn to scale. As long as they have some sort of ability for us to visualize what this situation looks like, if it turns out that, let's say I make angle 7 larger in my drawing, but it turns out to be smaller as a number, okay, that just means I'm bad at drawing. And trust me, I am very bad at drawing. Thankfully, the iPad is doing a lot of the heavy lifting for me here to make it look like I'm not as bad at drawing. But similar idea. Make sure you're reading your directions or looking at your drawing to make sure it makes sense what you're going to say about these things. Complementary means here are two angles that add together to equal 90 degrees. And if you even wanted to write that first, before you go and fill in that, yes, here are the two angles that I have, angles 7 and 8, and then go ahead and do your math, great. Whatever it takes for you to get what you need to get for your final answer. Again, not trying to make this the worst thing in the world. And I'm even going to stop this question here because I want to make sure we can move forward and find something else. X is going to equal, I believe it's 11. And plug it back in, you'll get two angles that do in fact add to 90 degrees, and that's the goal. But I'll have the notes for questions, I think 1 through 13, given to you as soon as I possibly can. Again, this video is not just for, hey, copy down everything I'm doing. It's to show you just an example of all these different types of questions so that you're going to be able to practice them on your own for the rest of this period. Question number 5 is where things start to get a little bit more complex, because now you'll notice we're given 3 things. Here's a 5x, here's an 11x, here's a 144. So good news, one of them just has a number. The problem that you're going to notice here is that we don't, first of all, have the lovely angle 1, angle 2, angle 7, whatever. We will actually have to do the connect the dots and figure out where we're going. The other problem with question number 5 is a lot of people look at this and say, wait, I only see 2 angles. And sure, I do see a couple of angles here that jump out at me right away, but please don't sleep on the fact that they are just part of a larger angle themselves. And so when you're going through questions like this, it's important not just to make sure, oh, I'm going to label what I know, but please make sure when you have angles that overlap in some way that you're showing me exactly how you know where they're supposed to live. I can show you a little bit of a trick on how to do that. But again, when you go to label angles, it is just a matter of connecting the dots. Here's B, S, U. If I can see where those 3 dots connect, that makes it very easy for me to decide where I'm going to put that 5x. So I can visualize what it is I'm about to have to do. USH, USH, connect the dots. This angle right here is going to be my 11x. Cool, seems easy enough, seems reasonable enough. And then angle BSH. Hello, time limit. Is going to be the whole thing. And in that case, when you have a little 5x and a little 11x already in there, something you're going to see me do fairly often is this. I'm going to label this entire angle with, it could be 1 curve, it could be 2 curves, whatever, just to show, hey, right now, what I'm going to do in purple, what I'm going to show you in my notes is talking about this entire angle. It's not stopping at this line, it's continuing all the way through it. And even if I decide to write the 144 out here, at least hopefully that's not confusing you by thinking it's going to be this little one or it's going to be this little one. That 144 is the entire thing. Luckily, this is the easiest equation that we've done so far, because all this says is, oh, I have 2 adjacent angles. They share that line in common, and together, when I add them up, I get the entire large angle. That's the exact situation we're seeing right now in question number 5. Here are 2 small angles that combine to give a large one. And if you see that, congratulations. I take my two small pieces, I add them together and get my large piece. This is very much meant to be the easiest math that we've had here so far. The example that you'll see about this when I ask you to do it yourselves, maybe we'll even start on that in this video so you can sort of see how it goes, but similar idea to all of that. Of course, I'll have in my notes, hey, let's divide both sides by 16 here. That's why I magically get x equals 9. And then it says to just solve for x and find the measure of angle BSU. Congratulations. That's going to be very, very easy, hopefully, to just say, oh, look, that's BSU, make x equal 9, and 5 times 9 says that that is a 45-degree angle. I do, of course, encourage you to please go back in and double check all of your work. Don't just assume that you got the correct value of x. Make sure that when it plugs back into everywhere else, 11 times 9 is 99. 99 plus 45 will give you 144. So that is your correct answer, but feel free, please, to answer more than just what is asked. That's the first 5 questions, and then we get to questions 6 and 7. The last ones I'll go over with you, but they're going to involve a new word. This is the one that we skipped on page 1, so let's go back, let's talk about that, and how that's actually similar almost to what we just did. Because you'll notice the drawing here for angle bisector, that bottom right box on page 1. Looks pretty darn similar to the adjacent angles we've already done here. And it will involve a pair of adjacent angles. The difference now, angle bisector, if you want to go by literally treating this like it's an English class, bi, the prefix means two. Sector, or sections, parts. We are talking about an angle that is divided into 2 parts. The thing that we call an angle bisector is the knife that cuts through it, the like whatever you want to say. This is the angle bisector itself. It's the thing that does the cutting. The angle that gets cut, of course, is the large one. But you can see the definition sort of right below it. And then it says, if this ray AB bisects angle CAD, the one that I've just highlighted in blue or traced out in blue, then that means not only are these 2 angles, let's go here and here, adjacent to one another, they must in fact be equal. They have to be the same. If this small angle is 27 degrees, then this small angle has to be 27 degrees. You saw me label an angle with 2 curves just recently. Take a look at what's going on down in this corner. Whenever you see in a drawing that multiple angles are labeled in the same way, both of these have a single curve and one, we call them tick marks, you might just hear me say marks going through them, boom. You might even see them like drawn further out so you don't get confused. It's not like one big curve. It's saying, oh no, those 2 little pieces, they must be exactly the same in every way. So if you do see that angle bisector thing going on, then no matter how many degrees that first angle is, the second one has to be the same. This means actually if you're told that there's an angle bisector, the bad news is that sounds complicated and it sounds like you're going to have to think a little bit more. The good news is, in a question like 6 and 7, where I'm very boring and gave you the same drawing twice and the same directions, this means you start the problem immediately knowing something very, very important. In question 6 and 7, EF bisects angle DEG. Bisects means it's going to cut it into 2 equal pieces. Before I even start this problem, before I even go to draw anything in, the very first thing I'm going to do with this information is this. And let me make those curves a little bit cleaner so you can see what I mean. Here is an angle, here is an angle, they must be the same. You might even see me in the future do it with, I'll label them both with 2 curves. If they have the same number of curves with the same type of markings, they are the same. They are the same measure for those angles. However many degrees one of them is, the other one will be the same. That is huge. That before we even write anything in with numbers or variables, we already know that 2 angles here are the same. And spoiler alert, questions 6 and 7 are the same. So I'm just going to go ahead and say, oh, look, see what I was able to do there? I'm able to do it down here as well. Before I even get to writing anything in these problems, those 2 angles got to be the same. Then I can go and actually look at question number 6 and say, the measure of angle DEF is 3x plus 1. DEF, connect my dots. I've got this angle right here, and this is a 3x plus 1. The measure of angle DEG is 5x plus 19. DEG is 5x plus 19. That's a little bit trickier. And again, this is why sometimes you'll see me do this little curve that says, oh, look, I'm talking about the whole thing now. That whole angle is 5x plus 19. Now, the common issue that you'll often see with these problems is, oh, look, I'm given one piece of information, I'm given two pieces of information, and I'm told that there are two angles that are the same. The most common incorrect answer to this problem is to start this equation by saying this, to say that 3x plus 1 is equal to 5x plus 19. It's an easy trap to fall into because they're the only two pieces that you're given information about, and you were told by the directions that two things had to be the same. But it's clearly not those two things. You saw me trace those two angles out. This one in purple was much larger. This is where you have to be careful with what this information actually does mean to you. The fact that EF bisects angle DEG. The reason why we wrote these curves in here is to help you recognize, as soon as we got to this piece of information that said angle DEF was 3x plus 1, as soon as I see that this angle right here is 3x plus 1, congratulations, any angle that's marked the same way has to also have that same measure. If angle DEF is 3x plus 1, then angle FEG has to be as well, because that's what we were told by this whole bisect business. And that means this question isn't saying set two angles equal to one another. This question, rather, is like the exact three questions that came before it. I'm sorry, the four questions that came before it. In question number 2, oh, sorry, no, that one was different. We did say these two angles are equal. But in question number 3, here are two angles that I am given, together they make a straight line. So angle plus angle equals 180 degrees. In question number 4, angle plus angle equaled 90 degrees. In question number 5, angle plus angle equaled another angle. This is going to be another example of that. We are saying here are two smaller angles that add together to equal the larger angle. Now here we had 1, 2, 3 pieces of information we were given, 5x, 11x, 144, and we could make something that says 1 plus the other equals this whole big thing. The hardest part about this question is understanding you do have two small pieces. They just happen to be the exact same piece. That 3x plus 1 plus another 3x plus 1 will give you that entire 5x plus 19. And once you have that information, then you're going to go ahead and finally solve this equation. The same way you would do it with anything else. Step 1, combine your like terms on this side. Before you start moving stuff from one side to the other, make one side as simple as it can possibly get. Now on the left, you only have a single x term, a single number. On the right, you only have a single x term, a single number. Then you can get down to the business of moving things from one side to the other. And heck, this equation now is going to look very, very, very nice. I subtract 2 from both sides, and x is 17. Now, please be careful again. This question doesn't ask you to do anything besides find the value of x. So if you want to say you're done, cool, you're done. And that's fine. I would highly, highly suggest to please plug back in and make absolutely sure that when you put the 17 in here and you put the 17 in here, you get something that makes some semblance of sense. That when you say 3 times 17 plus 1 or 51 plus 1 is equal to 52 degrees. And okay, this angle is 52 degrees. This angle is 52 degrees. 52 plus 52 is 104. So if I don't get 104 by plugging in here, I've definitely done something wrong, whether it's the plugging in or whether it's the algebra itself. So please always have that in your back pocket for at the end of this question, even if it's not something I'm asked to do. Let me go ahead, plug back in, make sure I get something that makes a good amount of sense. Don't just assume, of course, that all questions are solved the same way. If you look at questions 2 through 6, the ones that involve algebra, every single one of them has been solved in a slightly different way. A lot of them were one angle plus another equals some number or something with variables in this case. But it's the setup, it's how we understand each question that is the most important thing. I'll do one more of these, question 7, and then I'd say you're good to go for probably a lot of the rest of the packet, but definitely focus on questions 8 through 13 after this. Same deal though, we'll go down to question number 7. We already have, because of the whole copy paste thing I just did, the idea that yes, there was an angle bisector, so these two angles have to be the same. Cool. DEF says 5x minus 3. So I'll still put my 5x minus 3 in DEF because that's what happens when I connect the dots. And then the measure of angle FEG is 2x plus 15. Well, would you look at that? This one's not so complicated after all. I look at this drawing and I say, okay, these two little angles are marked the same way. I guess that means that those two things that I see there do in fact have to be equal to one another. I'm not saying that it won't ever be the case that you just get to go in and say, I'm only given two pieces of information. They must be the same as one another. Hooray. No, that totally is going to happen every so often. Just please make sure that you have a reason for why you're saying it. You're not just trusting that things are correct. You're actually going ahead, you're doing the math, and you're seeing that x is equal to 6. Plug it back in and make sure that you get something that makes sense. But here I believe you get two 27-degree angles, which would make a 54-degree angle, but we weren't even told anything about the big one. As long as we just see that, yep, 27 makes sense here, 27 makes sense here when I plug it in, and yep, that's an angle bisector, all right, then you'll have the information you need and you'll be able to finish the thing off. Again, I sincerely apologize that I'm not there in person to help you through these kinds of questions, but here we have seen pretty much one example of everything else that you'd see in most of the rest of this packet. But again, my suggestion to you, now that you've seen these, you can obviously go back, look at these. I've talked very quickly, but that's the benefit of a video. You can pause, you can rewind, you can go back and see anything again. I'd say any of the questions now from 8, 9, 10, 9 and 10 look very familiar right now based on what we just did. But here's 11, 12, and 13. I will make note of this right now and just say it. Some of these questions will have fairly weird answers, perhaps, based on what you're thinking. At least one of these will give you an answer where x is negative or r is negative or whatever variable happens to be. Please don't freak out when you get a negative variable. As long as when you plug it in, you get something that is a positive number of degrees, you're good. Likewise, if you get an answer where your variable is a fraction or a decimal, as long as you plug it back in and you get the numbers that make sense, fractions and decimals are fine. You're always going to have access to a calculator in this class. So with that in mind, again, please don't freak out when you see questions like these. You're just going to go through the next two pages, 8, 9, 10, 11, 12, 13. In fact, I think you could probably do 14 through 16 pretty well as well. 14 and 15 are kind of like the delta math problem that you'd already done. So with that in mind, again, please try your best to get through those. I'm not going to give you official homework from this today. You will have some homework. You will have some work to do in delta math in our next class on Wednesday. But again, my sincere apologies that I wasn't here to be able to say this to you in person and give you these notes in person, but my full set of notes with the color coding ridiculousness will be coming in Google Classroom, hopefully very soon. As soon as I can get to it, I will send it to you all. Thank you all so much for listening to all of this. If you have any questions for me whatsoever, I'll say it in the Google Classroom, but I'll say it here as well. Please send me an email. I'll try my best to check during the course of the day, during the course of this period. But please just let me know if anything jumps out at you as, oh wait, that was really difficult and I need a little bit of an explainer or a refresher. Thank you everyone and take care.